Okay guys, so this is the 6-4 part 2 notes. I am now on page 8. So we did this in class yesterday, so now we're going to be doing this. I'm on page 8 like I said. If you look at this, there's all these rules that are from your textbook that involve some trig functions and also involve some natural log functions, but here are the ones I really care about, okay? I really care about this one, that you remember that the integral of 1 over x dx is just going to be the natural log of the absolute value of x plus c, and also number 10 here. Okay, we're going to do a problem with number 10, that the integral of a to the x power dx is equal to a to the x divided by natural log of a. That comes back, that's from a while back when we were doing derivatives, okay? One other thing I want you to talk about is, as we said, that the derivative of sine, of sine is cosine, which would mean that the integral of cosine x dx is going to equal the sine of x. That's the antiderivative, right? Also, if we're talking about the derivative of the cosine, it would be negative sine. So it would make sense then that the integral of sine dx is going to equal negative the cosine x. So those are some things that you should remember. All right, so let's do some of this trig right here. All right, so from here, the first thing we're going to do with this definite integral is we are going to find the antiderivative. So the antiderivative of 1 is just x. The antiderivative of cosine, like we just said on this previous screen, is going to be sine x. So I'm going to get 1x plus sine x, and I need to evaluate that from pi over 2 to pi. All right, so you just need to remember a little bit of your unit circle. So as we remember from the fundamental theorem of calculus, it's going to be f of pi minus f of pi over 2. That would be the area under the curve. So if I did f of pi right here, that would mean I would plug in pi for x, so it would be pi plus sine x. Sorry, that should be an x there. Sine of pi. All right, so if you're remembering on the unit circle, pi is right over here, and that coordinate right there is the point -1, 0. So your sine in that case is 0. So you would get pi plus 0, which is pi. Okay, so that's f of pi. All right, f of pi over 2 is going to equal pi over 2. I'm just plugging in for the antiderivative right there, plus the sine of pi over 2. Okay, pi over 2 is up here. Those coordinates are the point 0, 1. So in that case, this is going to be sine of pi over 2. This would be pi over 2 plus the y coordinate is 1. Okay, so that's your f of pi over 2. All right, now when I follow this, I would get pi minus pi over 2 plus 1. So distribute the minus sign, and you would get pi minus pi over 2, which is just pi over 2, and then distribute that minus sign to the 1, minus 1. And that would be your answer. That would be the area under the curve if you graphed that 1 plus cosine out. Okay. Let's now do this one. It was the integral, it's a definite integral from -1 to 2 of 3 to the x dx. Again, if I go back and I look at number 10 in those rules, I would get a to the x over the natural log of a plus c. So here, let's go do that. This then would be, the antiderivative would be 3 to the x over the natural log of 3. And I would do that from -1 to 2. When I do that out, I would have to do f of 2 minus f of -1. So when I plug in 2, I would get f of 2, I would get 3 squared over natural log of 3, which comes out to be 9 over the natural log of 3. When I do f of -1, I would get 3 to the -1 over the natural log of 3, which comes out to be 1/3. So it's 1 over 3 natural log of 3. All right, to finish this up, in order to subtract, I would do 9 over the natural log of 3 minus 1 over the 3 natural log of 3. All right, And to make this even simpler, more simplified, I should have a common denominator. If I wanted to, I could multiply this by 3 and this by 3, and I would end up getting 27 minus 1, which is coming out to 26 over 3 times the natural log of 3, and that would be my answer. Okay? All right, now I want you to move on to the 6-4 part 3 notes. Okay, we're going to do this quick do now here. So think about this. If I wanted to find the antiderivative, I'm looking at the definite integral from 4 to 9 of f prime of x, meaning I wanted to find the antiderivative of f prime of x. Well, wouldn't that just be f of x? That's the antiderivative. And then from there, I would evaluate it from 9 to 4. So I would get f of 9 minus f of 4, which in this case, it's just a lowercase f. So it's be f of 9 minus f of 4. Sorry, lowercase f of 4. Okay? All right, that's the do now. All right, I want to talk about this really quickly. If you're making the assumption that this is odd symmetry and there's a period of 2 and this is all kind of symmetric here, and also you need to know this, that the definite integral going from 0 to 1 of f of t dt is 4/3, okay? So what that means by that, guys, is that going from 0 to 1 right here, this area between the curve and the x-axis is 4/3, okay? So now notice this. Notice what my variable is. It's the upper bound, okay? So if I wanted to do this y chart, it's an f of x chart, I would be saying, well, what is, for this first one, when I plug in -1, 0 to -1 of f of t dt. Okay, see what I'm doing here? I'm plugging in for that x, that upper bound. So in that case here, that would be going from 0 to -1, okay? That would end up being, what is that down there? That would be -4/3, wouldn't it? Okay. However, I got to think about this. In this case here, it actually would be +4/3. Even though it's below the x-axis, think about this. I'm going from 0, if I was going from -1 to 0, then my answer would be -4/3. But if I'm going backwards, wouldn't it be negative that? So it would be negative that. So it should be 4/3. Okay, what about going from 0 to 0? This is this next one, from 0 to 0. Wouldn't that just be 0? There's no space under the curve. All right, the next one would be going from 0 to 1. Well, we already knew that because we have it right here. It's 4/3. Okay, and then the next one is going from 0 to 2. Well, from 0 to 2, well, if this is 4/3 up here, wouldn't this be -4/3? And so it would be 4/3 plus -4/3, which is 0. And then the last one would be going from 0 to 3. If I'm going from 0 to 3, I got 0 plus another 4/3 over here, so this would be 4/3. Okay? Don't worry too much about that. All right, here's another one here. I have in this example here, okay, I have the definite integral, g of x is equal to the definite integral of -2 to x of wt dt. So when they say what is g of 0, they're asking you what is the integral from -2 to 0. I'm plugging in the 0 to that upper bound again of wt dt. Okay, so if I look at this, I'm going from 0 to -2. All right, I'm going backwards, but look, check it out. This is 1/2 by looking at it, okay? This area is going to be -1/2, okay? So it would be -1/2 plus 1/2, which is 0, okay? Next one, what is g of 2? That means I'm going to plug in 2 to the upper bound. So if I'm going from -2 to 2 of wt dt, well, now I'm going from, here's -2 right here, -2, and +2 is over here, +2. So we already determined that this plus this is 0, so it cancels each other out. All right, and now I've got this is 1, this is 1, and this is 1/2, and this is 1/2. So all together that area is 0 plus 3. So it comes out to be 3. All right, the last one I'll do in a different color. Let's do it in red. So now I'm going from -2 to -3. Now I'm kind of going backwards, okay? So this is interesting. So I'm going from -2, which is right here, to -3, which is right here, okay? So I'm going from here to here, all right? Now, here's the thing. Again, if I asked you, what is the integral going from -3 to 2 of WT dt? Well, you would say, well, this is 1/2 and this is 1. So my answer would be 1.5, except that it's below the x-axis, so it would be -1/2, -1.5, right? But I'm not asking you to do it that way. I'm asking you to do it this way, going from -3 to 2. Actually, no, I take it back. This is wrong. Hold on. I am going that way. I'm going from I'm going from -2 to 3. So I am going backwards. So because I'm going backwards, it's going to be negative this. Okay, so it would be -1.5, which actually would come out to be 1.5 or 1.5, positive 1.5. Okay, I know that's confusing. All right, moving on. We want to derive a formula, and this is way easier than it's going to sound in the beginning. Okay, so if I were to find the definite integral from a to x of h prime of t dt, where a is a constant. Now that's an important thing, that a is a constant. Here's what I would find. I would find the antiderivative of that, which is just h of t, because if that's the derivative, the antiderivative of that would just be h of t, and I'm going to evaluate it from a to x. So that's going to come out to be h of x minus h of a. Okay? All right, now I'm on example 10. What if I were to find the derivative of this? Well, let's think about this. The derivative, it would be the derivative of this. Okay, now if I were to find the derivative of h of x, wouldn't it just be h prime of x? And if I were to find the derivative of this, h of a, well, here's the key. I told you that a was a constant. So h of a is just going to be a constant. And what is the derivative of a constant? It's just it's just 0. So what I end up getting out of this is h prime of a. So now, like I said, that sounds very confusing, but the bottom line is all that this comes out to be, and this kind of makes sense, I think, because it's kind of as if the derivative is undoing the antiderivative. So all you're going to do here is you're going to take whatever that variable is in your upper bound and substitute it in here. And so this is the fundamental theorem of calculus in antiderivative part, and they're calling it the part 1 version or the simple version, okay? So all of that means, after all of that, is that if I had something like this in example 11, if I told you that g of x was equal to this, and I wanted to find the derivative of this, it would just be w of x. In other words, I'm just substituting in one variable for another variable. That simple. And if I move down to example 12, this is simple as well. I am taking the derivative of the antiderivative, and so all I'm going to do is take that x and substitute it in for the t's. So this answer would end up being 5x squared minus 6x plus 1. Okay, that's it. That's it for today. We're not going to do any of this after that, but what you need to do now is check on Schoology, and I have a worksheet for you to do that is due tomorrow. Don't forget, I will be checking your notes. Thanks, bye.